What is up, car and tech fans? Welcome back to another garage tinkering video. Today, we're actually going to take on what I think is the most requested video that I get: how to migrate from using Arduino IDE to using PlatformIO. We'll look at why you would want to do that, and then look at the steps you need to go through for the first time, setting it up with VS Code, and then migrating a project from the Arduino IDE setup that you might be used to through to PlatformIO itself. So why would you want to do this? Why is PlatformIO considered that much better than using Arduino IDE? And it comes down to a couple of key factors. The biggest one, in my opinion, is the ability to define very specifically all the libraries and setups and tool chains that a project requires, so that when I'm creating something that then goes onto GitHub that you guys download and use yourselves, I don't get hit with all of the questions of, oh, what version of the plugin are you using? Or where is the repository for this library? Everything can get defined in a setup file, which means you can just download and run it without having to worry about, oh, are things all the correct version? Or is my project set up in exactly the same way as the way Andy is doing it? With PlatformIO, we can define that setup as part of the project, meaning its reusability is much better. And for me, if that alone was the only improvement you got from Arduino IDE, I still think it would be worth it because it is so much better. As part of that, it removes the single global libraries folder issue that you get in Arduino IDE, where you might want to use different versions of a library or modified versions of a library between different projects. Because each project now has its own referenced library, you can use modified or altered versions of anything that you want to include and it not automatically affect any other projects that you might be working on. Also, it means we move away from using the Arduino IDE and start using VS Code, which has a lot better error finding, syntax highlighting, and the ability to do little things just like clicking on a function and going through to where that function is defined. It makes moving around your code and isolating issues and finding the root of things for perhaps comparison, which we're going to see today, much better. So let's take a look at migrating a project with some dependencies and some, sub pages that are being used in it from Arduino to PlatformIO, and seeing exactly what that process entails and what steps you might have to go through, because there are some things that might catch you out depending on how it's being done. If you've been following my channel for a while, you might recognize this quite simple bit of code. This is a gauge setup file that runs on my own ESP-32 S3 powered boards, which power an LCD screen, and it's designed for making gauges for your car. There is the root file here. All it does is initialize all of the different subsections, things like the I2C, the IO extender, the screen itself, LVGL, all that kind of stuff, and then draws a spinner on the screen. In fact, if I run this code and get it actually connected up to a board and upload it, we'll see this spinner spinning on the screen. So we've got the root code. This is an INO file. It's INO because it's the last 3 digits of Arduino. And this is where you create your crux of your application. This is where it comes in and it starts reading, and then from here we can go down into these various subfolders. So I've got these pairs of header and CPP, which is a C++ file. So these are in pairs of the display, the canvas, the I2C, LVGL driver, and this TCA 9554, which is my IO extender. So these are just all in pairs, and it's relatively simple, just lots of initializations and setup to allow the board to work. But we're going to change all this into the format required by PlatformIO. So let's migrate this entire project to PlatformIO. In order to do that, we're going to need VS Code, and we're going to need to set up PlatformIO. I've obviously done it before, but I've now ripped it out of VS Code, and we'll start from scratch as if you're following this and you've not actually done it before. So if we bring up a brand spanking new VS Code, which is what this is. You'll slowly learn your way around this as you're using it. But the core things that we're going to want are these on the left-hand side. And if we go to extensions, I obviously have a bunch of other stuff already installed in here. But one of the ones we don't have is PlatformIO. So PlatformIO, there we go. Got the little alien face. Install, that'll install. And then PlatformIO will be available on the left-hand side here, which means we've got it up and running. So this is the PlatformIO homepage. It gives you a little bit of a how-to, but we're going to assume that you're following me. So we'll just create a new project. But if you don't already have a place where you want your projects to live, you might want to pick a folder. But yeah, in here, we'll create a new project and we'll call this one My First Gauge PIO. So it's just my PlatformIO. And the kind of board that this is set up for is an ESP-32 S3. It's an Espressif dev kit N8R8. So that bad boy. And we're going to be using the Arduino framework, use the default location. And it will take just a second. And then we have this on the left-hand side. So a few files will open and close. PlatformIO home we're not going to need again right now. And like I said, each PlatformIO project has a setup which allows you to define all of the libraries and the things that are going to be used within it. And that's what this platformio.ini file is. It's the initialization file, initialization. And this sets up a bunch of stuff. So at the moment, we've defined that we're going to be using the Espressif platform. Our board specific that we're going to be using is this one, the S3 dev kit C1 N8R8. And we're using the Arduino framework. There is more stuff that we're going to put in here, but we'll get to that one little bit at a time. Within this, instead of just having a folder, and in that folder we've got a .ino file and then our various other files, we end up with a selection here. So the ones that have started with the dots, so .pio and .vscode, you're probably rarely going to touch. But what we do want to think about is, well, it includes libraries, source, and then test. But our main entry into this application is now main.cpp, main C++. So this is the equivalent of your .ini file. And if you see in here, the setup is very, very similar. In fact, it's the same format, really. You've got your include, which is include Arduino.ide, which we do need to include in this. In Arduino IDE, we could get away with not putting that in here. We will need it. We've forward referenced a function here just so that it appears above the places where it's being utilized. And we've got a setup and a loop. This is all fine. One thing we do need to do is just select where our board is connected. So if we click this auto at the bottom, we'll get a choice of a few, and it's 23. And then because we're using PlatformIO, instead of just when in Arduino IDE we had tick to verify the code and then upload, we've got a few different bits. So we've got build, upload, clean, test, serial monitor, and new terminal. So these all do similar but different things. So build is the same as what you would do in verify. Runs through all your code, runs through all your libraries, compiles it all together and makes sure that it can create a block of code that is going to successfully run on whatever microcontroller you're using. I use successfully there because you can definitely upload code that works but doesn't work. Upload does exactly what you think it does, takes the code and throws it onto your controller. Clean will remove everything that's been compiled, because the joys of doing it with PlatformIO is that as you recompile things, it will do it more quickly and more efficiently than Arduino IDE does, because some stuff that remains untouched, it just keeps that precompiled and then just adds your changes onto that. Clean will remove everything and basically rebuild everything from scratch. It is very useful, and you will see why later on. Test will run test scripts. We're not going to worry about that too much right now. serial monitor, same as it does with Arduino IDE. Watch your serial monitor. And terminal, we'll just click on that one, is if you wanted to run some commands directly, you can do things like flushing caches, or, you know, there's thousands and thousands of different commands that you can run, but it means you can run code directly on your microcontroller. So we want to put all of the code that we had in the other version, in the Arduino IDE version of this code here. We're going to put them into here. So how do we do it? Well, let's start by taking the entire INO code and just pasting it over the main CPP. Step one done. Then, if I open up my folders and I go to Arduino, this is where I keep my Arduino files. I'll go to the first one that we're looking at, my first gauge, and I've got all of these except for the INO file. And for now, we'll just pop them into source over here. So now all of these files have been migrated across over here, and we can look at them exactly the same way as we did before. You might think, oh great, well then I can just compile that and it'll work, but it won't for numerous reasons. For example, LVGL has not been found, because when we had it in Arduino IDE, when we were looking at it here, and we use LVGL driver, and that has LVGL, this uses a common folder full of all the libraries. So it's there. It knows LVGL is there. With PlatformIO, it doesn't have that common library. So we need to tell it to utilize LVGL in this project. And there are a few ways we can do it, but it's why we start to use this PlatformIO INI file. And we want to add into here the dependencies that we require for our project. Now, sometimes once you know them, you can just list them in here in a specific format. But when you don't know them, if we go into PlatformIO Home, and then on the left of this, we've got libraries, and we can search for LVGL, search, and here is LVGL. Most common libraries, things that are very, very popular, will be in here. But there are some that won't be as well. So we'll see one of those in a minute. So if we click on LVGL, version 9.3, we want to add it to our project. The project we've just made is my first gauge. And then add. Just give it a second. It's basically going to re-download the latest version of that code, that 9.3 code. Use it for this specific version. There we go. And then put it in this library dependencies list, which is in this platformio.ini file. So now when you press this compile or this build button, at the moment we've got LVGL, no such file or directory. We're probably going to get other issues along the way. Yeah. So here's another dependency. ESP-32 CAN isn't found, which is a popular CAN bus plugin, but LVGL is now found because we've included it in this library dependency. So what happens when we want to use ESP-32 CAN? We can go back and do the same process. So open up PlatformIO Home. You can also just click this button at the bottom, this home button, which will do the same thing. And again, we're in libraries. We want to search libraries for ESP-32 CAN, but that gives us no results because ESP-32 CAN isn't a super popular one and it isn't, widely distributed. So how do we get it into our project when it's not available in this library? And all we have to do is search for where we know it to be in its repo. So this is the one. It's by Colin80, ESP-32 CAN. We take that link, copy that, come here, and then we can do basically that. But I know that this current version works perfectly. So for this particular project, I want to define the version as being this one that is currently being used. There are a few ways that you can see version, but one of these is just going to library properties, and there, version 0.3.1. So if I come back to here and do at 0.3 0.1, that means if you are to download this code and you use this project, you will use ESP32CAN at version 0.3.1, which is why I say it makes the sharing and reusability of code much, much easier, because I am defining all of the libraries that are required. And when you use this, it sets up all those libraries in exactly the same version. So it should mean it's a lot easier to one click and just get going and everything is set up. This is the big advantage of PlatformIO. Now, ESP32CAN actually has a dependency, which is also written by Colin 80, which is can common, which is this one. So we need to do exactly the same thing. Take the URL for can common, and then at whatever the latest version is. I happen to know it's 0.4.0, but let's check that here. Yeah, 0.4.0. So now these two are also included. So LVGL is set up, ready to go. Can common and ESP32CAN are all set up. So if we save, we'll see some stuff run at the bottom, and you'll see it'll do this library manager. So there we go. Can common was set up, it said, and then ESP32 common was set up. Basically, there we go. It's all been successfully updated. So all of these plugins are now available in this code. So if I go to run it again, I am going to get some errors, but we'll notice it gets past these first things that it was having errors with. It was saying LVGL not there or ESP32CAN not there. Those things have gone away because we're now defined in this initialization package where those things that we will require are. Now, it is important to note at this point that Arduino IDE and the version of the Espressif toolchain, the Espressif code that it uses, can be different to what we use in PlatformIO. So there will sometimes be differences between the code that catch you out. It's not just a case, as we've identified here, that copying from one to the other, copying your main INO code into this main CPP code won't always just happen. It won't just be tickety-boo. Sometimes you will need to go in and change it. And for this migration of this project, there are a few things we need to change. For example, it says here, LCD clock source default is not declared. So this is something that comes in through one of the ESP Espressif definition files. But in the version that is in for PlatformIO, it's not defined like clock source default. It actually gives you suggested alternative, which is this xtal, which is actually the answer for the one we want. So we need to go to where the code is. And this is one of the big advantages of using PlatformIO over Arduino, because we can do things like hold control on my keyboard and click things, and we'll go to where we need to go to. For example, like that. The error definitions and stuff like this, and actually saying where the problems are, is typically much better in VSCode than it is in Arduino IDE. So this one needs to be this xtal. And then if we scroll through here, we'll see some other stuff. So these kind of red squiggles are telling us that there are errors throughout this bit of code. So ESP LCD RGB panel config type has no field bits per pixel. So either the version we're using here is newer or older than what we were using in Arduino IDE, and subsequently this particular line has been depreciated. You might not want to just rip it out for now, so we'll just comment it out. And we can do the same through all of these errors along here. So LCD panel has no field, num FBs has no field buffer size. Everything else seems okay. And what's this one? Out of order initializers are non-standard in C++. So these are the initializers, and it's telling me that they are out of order. So if this was in C, because they're named with these dots, you could have them in different orders. In C++, they have to be in the correct order. So I don't know what that order is. But if I hold Control and click on for that, I'll go to here. This is the structure. So this, if I pull it over to the right, we can then match up the two. So clock source, timings. So what we got down here, GPIO nums, and then GPIO num. So in this new version, this bit here comes before the display GPIO num. So data comes before display, whereas the other way around here. So Alt and move it up one. So now those are in the same order. And just check down here. Okay, flags again has some fields which are no longer used. So that should have successfully changed that. Now, it might not always be this simple, and there are going to be a number of times you're going to be chasing your tail. That's coding for you. So if I compile this, we have errors, which is fine, because what this is doing is looking for LVGL's conf file, and it's not finding LVGL's conf file because we haven't set up LVGL's conf file. So how do we do that? Well, if we come up to the top to PlatformIO, library dependencies, and in here we have the libraries that we've included. Now, if you've used LVGL before, you know it needs its conf file here alongside these folders. So in here there should be a template. There it is. Copy that, click on there and paste it, and then rename it. So that's my LV conf file, the thing that it can't find right now, because it expects it in a folder alongside LVGL's root folder. And then when we click on that, we need to just enable it with the one. And then my one thing that I like to do here, which is good for my board in particular, is change the memory size to 128. But other than that, I'm just going to leave everything else as it is. So when I run that, these LVGL errors should all go away. And like I say, a lot of this is just about once you've migrated it over, there's going to be a bunch of little things that you like chase down errors. But as you can see here, it's running through all of the LVGL to find now because it's found where that initializer is. There we go. It has successfully created my ESP32 image. So if I then feel like I'm done with that, I can upload it, give it a moment to rebuild. It's going to, build everything, connect to the port, run. And there we go. It is now successfully running the exact same code over in PlatformIO. It's doing the same thing. That's exactly what we wanted. But we might want to take it one step further and just make our lives a little bit easier when it comes to reusability. And again, this is one of the big advantages of doing things in PlatformIO is you have all of these subfolders with libraries and includes and all that kind of stuff, which allow you to make your projects more reusable. And that's definitely something we want to do, especially if we want to, design multiple things off the same base. I have this kind of like setup for my boards, and I'm going to use this for dozens and dozens of different designs across different boards, but I want to make the base, the core, the setup, the same on all of them. So I'll make it reusable simplistically. And we do that by utilizing the library. So if we get rid of library dependencies here, library here. So all of these initialization pairs, the C++ and the H file, we can think of kind of like its own little library. So for example, the canvas driver might be a canvas initialization library. So what we need to do is create a house for each one of these things. And it's dead simple. On library, we right click, new folder, and we'll call it the same name as what the entry file is, the CPP file or the H file. So this one's canvas underscore driver. We'll create that and then right click on canvas driver, new folder, and we'll create a source folder inside there. Then we'll take these two and put them inside that source. You can select either one of these. Make sure you select the source on the right. It won't actually list it out, but this is now library canvas driver slash source slash the two files. And if we repeat that for each one of these, we'll end up with this, where we've got each one of those things named exactly the same, and the subfolders are, well, there's a source subfolder, and then within that source subfolder, we've got all the other files. There is one issue that this is going to create, and it's because these are now determined to be not part of the project. So they're not part of the stuff that's within this source file. So when we're in the initialization here, these library dependencies are only available to the things within source. They're not available initially anyway to these individual libraries. So if we try to execute that code now, I know, for example, LVGL over here is where LVGL is called, where the library is called, and it won't know where LVGL is. So it's going to fail when it gets to that point. There we go. So the LVGL driver, this one here, actually, we don't need this one on the right anymore, uses LVGL, but it doesn't know where it is. So we have to add a way of that knowing where it is. And we just do it with some properties. So this LVGL driver in here, we're going to have a new file, which is library.json. And we just need to stick a little bit of code in there. I have it already. I'm just going to copy and paste it from elsewhere, but it defines a few little things. So a name, LVGL driver. So that's defining this little library. So what we're calling this little thing. So this is called the LVGL driver. It's version 1.0.0, and it has a dependency, and that dependency is LVGL at version 9.3.0, which means this library, these two files, now have access to that LVGL, assuming that it's been brought in successfully in your initialization file. If you took it out of here, out of these dependencies, it still wouldn't work because that is not then included in the project. It's needed in the project and in that library JSON. But as well as needing it there, there is actually if I just copy library JSON there, paste it into there, and then give this the correct name. So this one's display ST7701. Great, and that's its own new library definition. And really, you know, if you're going to be finicky about this, we should probably come in here, and each one of these has its own library JSON. So this one will be I2C driver. We'll just do that for all of the others as well. Okay, so each one of these now has its own library file. Just means that if we want to then make updates to this library and share this between other projects, we can keep track of the version, and it makes handling of those things a little bit easier. But again, if we just go to build, it should, I think, now compile everything successfully. Yep, and there we go. And if we upload it, we might have an issue, if I remember off the top of my head, because of something stupid. There is a particular instance that I have noticed during testing that when you're using Arduino IDE and you're setting up the board, one important thing is this USB CDC on boot is enabled. If you don't have that switched on, when you try to upload code to the board, it might do it first time, but then it doesn't go through the bootloader reset process properly, so you can't re-upload code. It's a particular thing that does happen from time to time. So if we want to avoid that, we need to just do a little bit of a add-on to this PlatformIO initialization. And it's, again, I'm just taking it from elsewhere, putting on these two build flags. So we're setting the Arduino USB mode to true, and then the USB CDC on boot also to true, which should get us around that issue and make sure that the bootloader thing happens every time, which it does. Great. So everything is good. This entire project has been successfully migrated over from Arduino IDE to PlatformIO. The big thing here now that we've got, which is advantageous, if we just shut down all these, like, close to the right. Oh, I've closed everything. It doesn't matter, it's fine. The big advantages I think we have now is our entire setup is done here in this PlatformIO initialization. So if I decide I want to add another dependency, we put the dependency in here. And if you're using this code and then you download this latest one of these, the first time you save it and run it, it's going to bring all these dependencies in exactly the same version. So duplicating the code will become much, much easier. Also, all of these libraries, these things that do all the setup, once we've got it right and working properly, as I do now for this specific screen and board combination, I don't really need to touch these again. I don't need to fiddle about with my I/O extender or with my I2C driver. They're doing what they need to. So I can just close up that library. All I need to worry about is this main file here, and then any other like subfiles that might exist around this in order to create this thing for this project. So if I'm doing like another small paired set of functions, I might create them in here. We could do, components, say, and within components have a new component, which is, let's call it comp A. And within comp A, there is comp A header file and also comp A CPP file. And then I can still utilize that from within here by including comp A.h. You can still, create, actually it'll be /components. Maybe that's why it's not found it. Components /comp A. There we go. Like I said, the error catching and all that kind of stuff, and the fact that you can, if I want to know what I2C init does, just hold control and click on it and go to the I2C init function. It's a lot easier to move around your application. So not only do we make it easier to share, we make it easier to navigate, easier to compartmentalize the parts of it and reuse them between projects or not reuse them between projects as we need. Hopefully, this should mean that if you do have a project that you've been considering moving from Arduino IDE to PlatformIO, this will allow you to do that successfully. Obviously, depending on the complexity of the thing that you've created and depending on the includes you've used and the versions of certain libraries and the versions of those libraries within the PlatformIO ecosystem, there may be a lot more or a lot less things you need to tweak in order to get it working. This isn't a catch-all. Not every single case is going to be the same. Some will be dead easy. Some will require lots and lots and lots of changes. It's just the way it is. But by doing this and setting it up like this, it means from here on, you can make things much easier moving forward. If you have any questions about this process or you're getting stuck in it, feel free to stick them in the comments and I'll try to help. Sometimes the issues are really niche and I don't have time to dig into a million rabbit holes, but you can either ask me in the comments or if you come over to our Discord, we've got a lot of people who are very well-versed in PlatformIO who will be able to help, and I'm sure would love to lend a helping hand. You can get the Discord link down in the description. Otherwise, we are going to, generally speaking, be putting Arduino IDE to the side for now and moving forwards with PlatformIO on this channel. Anyway, that's it for this one. I hope that something really good happens to you today, and I will see you in the next video, Wednesday at 2 p.m. Take it easy, peeps. Bye-bye.